Okay, we'll get going then. So morning everyone, and welcome to this case-by-case masterclass session on a Friday. So we don't usually do webinars on a Friday, but a special one for you today. At the end of what has been, in England at least, a very warm week, which has been very welcome. So for those of you that don't know me, my name is Nathan Harpham, and I'm a principal consultant at Agilicis. And today we are joined by Jessica Trong and Johan Stranderoth from Lersninger, who are going to be taking us through the case-by-case masterclass. So this very much follows on from Jessica's presentation at Joining the Dots, her keynote talk around planning and designing a safe system and modeling approaches that can support that. I'll give a brief intro, a bit of scene setting, and then I'll pass over to these guys to take us through the majority of the session. And then hopefully we'll have a bit of time at the end for some Q&A. So do be putting your questions and comments in the chat or using the Q&A function as we go. And then hopefully I can gather a few of those together and we can ask these guys at the end. Great, right, so Vision Zero in Great Britain. So Vision Zero has been adopted by a number of authorities now across Great Britain. So, for example, this is a statement from Vision Zero for London. It's neither inevitable nor acceptable that anyone should be killed or seriously injured when travelling in London. And with that, Transport for London have a number of targets around zero casualties with dates for those. Scotland's Road Safety Framework to 2030, it's unacceptable and unethical that anyone is killed or seriously injured on our roads. And these kind of statements and targets to go with these, typically to 2030, 2040 or 2050 for zero, are very prevalent now across authorities in Great Britain. But how are we doing and where are we now? So this chart's taken from the reported road casualties in Great Britain from the Department of Transport website. So 1979 all the way through to 2023, the reported road fatalities. And as you can see, fatalities have decreased quite considerably since 1979 on the far left of this chart. However, there's still a long way to go if we're going to reach zero. So in 2023, we had 1,624 fatalities. And importantly, looking at this chart, since 2010, progress towards zero has really stalled. With the exception of that bump during COVID, it's been largely flatlining with quite small decreases year on year. So there's plenty of work to do. And certainly within that, there's a need for data-driven solutions. So if we are going to hit Vision Zero and very much hand in hand with that, deliver a safe system, we need to know what to do. What do we need to do? What are going to be the key parts of getting there, delivering that safe system and hitting Vision Zero? And within that, certainly, we need good data, good analysis, and intelligence to tell us how we can deliver a safe system. What do we need to do to our roads to get the number of casualties down? And that's where I'm going to hand over to Jessica Trong and Johan Stranderoth to take us through case-by-case analysis. So I'll let you guys share your slides and take over. Thank you.
Thank you very much, Nathan, and a very good morning to everyone here. And those of you that I met at the Joining the Dots conference, it's great to have you join us again. Thank you, Nathan, and to you and Agilicis for inviting us to take part in this webinar to talk about one of our pet topics. So we want to talk a little bit more in depth today about a novel approach to data analysis called case by case that can help jurisdictions make more informed strategic and investment decisions. So it's an approach that Yuan and I have both studied extensively for a long period of time as a part of our PhDs. And now we're actively using this as a part of our consultancy to assist governments with their strategy planning process. So it's obviously something that is very close to our hearts and that we work with almost on a day-to-day process. And this is something that we believe can really sort of transform the way that we approach strategy planning and look at it from a different perspective. So the case-by-case process is usually done in combination with another process called backcasting. So we move to the next slide. As Nathan sort of mentioned, there are many governments around the world that are setting very ambitious targets. We've got the Decade of Action target of a 50% reduction in road fatalities and injuries by 2030. But many governments are actually being even more ambitious and targeting zero road trauma by a set date. So in many jurisdictions, that date is 2050. So in Europe, the US, in Australia, many of those countries are aiming for zero road trauma by 2050. And we move to the next slide. And that's a very commendable sort of ambition, because we know that setting ambitious targets comes with many benefits. It helps drive ambition. It gives us something to focus on. It helps, drive policy programs, innovation, investment in a topic that we all know requires a lot more investment. And while that is a really good thing for people to be setting very ambitious targets, we often say in road safety planning that it is not enough. Just planning for a reduction in road trauma is not a great indicator for how we want our system to look like. So in combination with actually setting ambitious targets, we need to sort of understand, what does that system need to look like in order to deliver on those ambitious targets? And this is where the process of backcasting comes in. So some of you may have heard me talk a bit about backcasting at the Joining the Dots conference. It's a planning process that differs very much from our current, more traditional way of policy planning. So with Vision Zero planning, we're saying, okay, we want a zero road trauma system by 2050. Well, let's backcast that. Let's start from the end. Let's start from the future. Let's start from 2050 and try to understand, what does that system that can deliver on that target actually look like? So do we want more pedestrians? Do we want more cyclists? Or do we want to be moving more vehicles? That is done as a part of our transport plan. And that's, whatever jurisdictions want, that is fine. But we need to sort of understand, what do we want that future mobility system to look like so that we can overlay the safety on top. So once we know what that safe transport system needs to look like in 2050, then we can backcast to our current state to understand, what are the policy decisions, interventions, and measures that we need to implement between now and 2050 in order to close the gap between where we are today to where we want to be in the future. I mean, that's a very simplistic, I guess, explanation at this time around what backcasting is, and Yuan is going to elaborate on it. But once we sort of have those policy programs in place to help us bridge that gap between now and the future, that's where case by case comes in, for us to understand, well, how close is the system that we've designed and imagined going to get us to our target? So that's a very brief introduction from me. Yuan is the true master in case by case. So I'm really glad that he's joining us here today to give you the masterclass on how it can be used for effective policy planning. So I'll pass it over to you now, Yuan.
Thanks, Jessica. Thanks for that kind introduction, and good morning to you all from Sweden. This is where I'm based. So a brief introduction to who I am for those who haven't seen me or met me. I'm Yuan, and I'm a consultant as well, working with strategy development for different jurisdictions around the world. But I'm based in Sweden, and here's where I've had most of my career. I've been with the Swedish Transport Administration, and sort of built the analytical framework behind Vision Zero, and sort of the analytical methods that we've used here in Sweden to set our targets and to develop our plans and the content of our plans. I've also worked and lived in Australia and otherwise around the world. So you'll see a few examples from around the world of analytics and of end states and other type of ideal future states, and it'll be from different parts around the world. We'll talk about case-by-case counterfactual analysis, as we've named it. But it's difficult to do that without the context of strategy development, because we want to sort of get you to have a feel for how we use it practically when we develop strategies. So we will go through sort of a strategy planning process, and in that sort of talk a little bit on how to apply this methodology in the different steps of the strategy development phase. So for those of you that were attending Jessica Trong's keynote and Join the Dots, there'll be some repetition for you, but hopefully you'll get some deeper knowledge into the analytical framework around things. So the first thing that we talked about was really around specify the vision, or trying to understand what that system look like. And of course, when we say vision zero, or we're talking about the safe system, we also need to sort of understand the safe system for who, because it's quite easy to make something safe, but how do we make it safe but also accessible? How do we make it safe while we still meet sort of our transport needs in our rural communities, in our urban areas, in our big cities, etc.? So when we say safe system, obviously it needs to be overlaid on our transport needs and on the way that we want to move in the future, and not necessarily only how we move around today, but more specifically, what do we see in the future in terms of how we get around when it comes to active transport, moving goods and people, and public transport, etc. So that's the basis of starting to understand the strategy development process, is to say something about what is our transport plan, what are our mode of transport, and how does safety overlay with that. The next step is to sort of acknowledge that we're humans and that we have a certain human crash tolerance. Our bodies can only take so much when it comes to physical violence in an impact. And if we want to be sort of moving in a truly safe system, we want to make sure that crash forces are never above those human biomechanical tolerance levels. And we've been feeded these type of what we can call boundary conditions on maximum impact speed for us not dying or getting seriously injured. And it's been very useful in trying to design a system where we don't crash head on above 70 kilometers per hour, or we don't have side impacts above 50, or we don't have vulnerable road user impacts or side impacts with trees in more than 30 kilometers per hour. And that's all good, but science has sort of taken us a long way from that, where we are a bit more advanced today to understand a bit more on the impact biomechanics, and how that relates to different types of road users, different ages of road users, and plus that we have a lot of modern vehicles coming into the market now, which potentially can brake before collision and bring down travel speed and impact speed before the collision, which means that travel speed could potentially remain a little what it is today and still be safe, even though it's unsafe for an old vehicle. So we're coming to a stage where we have a lot more knowledge on acceptable impact speed and thereby acceptable travel speed. And we can use this to design that safe system. But we need to know a little bit more about how this biomechanics. So if we combine what we talked about before, the transport plan, movement and place, or movement and links, with our biomechanical tolerance, with modern vehicle, we'll start to understand what our infrastructure and our urban areas needs to look like. But it is based on also that we accept that this is a holistic view that we need to have. It's a combination of vehicles, infrastructure, and of course, us as road users acting in this system. So we start by saying that, well, it needs, if we're aiming for 0 by 2050 as an example, we know that it normally takes 20 years to turn over a vehicle fleet. So it's really the 20 new cars in 2030 that's going to be the bulk of the vehicle fleet in 2050. So we need to understand what that vehicle fleet look like. What are those systems? How do they work? In what crashes and impacts do they work, and how do they work? And then get into the understanding of movement in rural areas, for example, to say that we have a high movement, high road movement, roads look in a certain way, intersections look in a certain way. And I'll just briefly go through this for context, and then we'll get into the actual analytics. So if we want high speeds, obviously we want sort of high level of potentially more costly infrastructure. If we're talking about lower movement functions and lower movement needs, we can afford to actually reduce speed limit and still maintain a good level of accessibility and transport, and combine that with a not so high level of infrastructure in terms of investment. So it's really that mix between, or that balance between high speed, lower speed, and infrastructure matching that speed in a safe way. Same in urban areas, but then of course we're talking still about the need for high movement and high functionality in terms of moving goods and people, but which are your sort of divided freeways in urban areas. But we're also talking about active transport, public transport, etc. And we're talking about solutions where we have mixed use traffic, where we mix vulnerable road users and cars and trucks, and potentially also public transport. So of course, a more complex situation, but also a very promising type of development that we see around the world, where we're going more towards acknowledging the need for more active transport, placemaking, etc. So how does that impact the way that we do our analysis? Well, what we do is to start to say that we're starting with a certain road stereotype, for example, the top right one here, and say this is the current state. That has a certain movement function and a certain functionality of moving goods and people. It's not a freeway, it's not a highway, but today it actually has a speed limit of 100 kilometers per hour, and it doesn't have very much of supportive infrastructure. And what we see as systemic crash types on that road is head-on crashes, single vehicle crashes, and some rear-end crashes as well. And we're sort of moving then to say, well, what do we want that cross-section to look like in the future? Well, we want a reduction to 80 kilometers per hour if there's no median barrier, supporting infrastructure on high-risk location with barriers and shoulders, delineation improvements, etc. So we're defining that future state for that particular movement function, which could be different if we're talking about a highway in this case, where it's a very high demand for movement. And in this intersection, as we see, there's still a high demand for movement. There's also a demand for access. And the systemic crash type here might be crossing crashes, right turn across paths, rear end crashes. And the current state is a speed limit of 100, still without no median barrier, etc. Poor delineation at grade intersections, at four-leg intersections. And the future, as we see it, to be safe, should be median barriers. It should be left in, left out, safe turning facilities, etc., which means that we can maintain that 100 kilometers per hour in a safe way. So we still have high movement, still high speed limit, but we support it with high level of infrastructure. And I don't think this is sort of rocket science in the sense that this is totally new. The new sort of aspect of it is that we're defining from the start what that 2050 image or picture should look like, to then move back and say, well, how do we close the gap between what it looks like today and the future state? And how do we use trauma modeling to understand the best way to get there and the most cost-effective way to get there? So the next step is sort of a system assessment or a gap analysis. And I'll move through this very, very briefly, but just to say that you can take a state, a jurisdiction, a country, and just overlay the assumption on what that future system should look like that we just saw, and say, what proportion of my current road network is actually looking like I want it to look in the future? How far away are we from that desired safe systems, and what are the current gaps? And I can start to break that down into my divided highways, my undivided highways, rural arterials, and say that there's certain proportion here that is acceptable, and then there's some that are not acceptable. And same in urban areas, of course. And by doing this, I'm moving away from just having a vision, a target of 0 by a certain date, to actually have a tangible gap to say, well, if that is to be true, here's a number of kilometers that I actually need to transform. Here is a number of intersections that I need to solve. Here is the placemaking that I need to do in my city. Or here are the policies in relation to road user behavior or enforcement that I need to implement. So it goes from being a bit blurry to hopefully a more clear action plan on what I need to do in the next 30 years or 20 years or 10 years, depending on how I've sort of outlined my targets. Now, following this, we're sort of going into the actual purpose of this presentation, which is case-by-case analysis. And because the question comes here really, where do I start? I understand my gap now, but where do I start? Should I start with my easy wins? Should I start with my high-risk road location? And how do I sort of do that over time? So that's where we start with a baseline modeling with case-by-case analysis, as we call it. And it sort of goes back to what Nathan showed in the beginning, where this is the trend for fatalities in Sweden, which sort of conceptually looks quite similar to the UK from the 70s, and actually look quite similar in all motorized countries, where we have a spike with motorization, and then we have a decline where we start to implement road safety policies. And with this, we can see that there's like a long-term trend. We have some ups and downs in our trends, depending on economic fluctuation or other spikes when it comes to seasonal variation or COVID or whatever it is. But overall, we have sort of a long-term trend. And the question is, of course, then, where are we going? If we just continue in terms of doing what we're doing, where will that take us? And how does that compare to the targets that we've set out? So conceptually, we have a retrospective trend. We have a target, or we have a business as usual development, where we say that we can just extrapolate this development in the future and see where it takes us. And then we want to compare that to a target, if, well, this case, 0 by 2050, and conclude that there's absolutely a gap here to say that if we continue as normal or just business as usual, we're not going to achieve that target, and there's going to be a significant gap in that target. So this is all guidance for us to understand how much we need to do. There's a few problems here, though, where traditionally what we've used to try to understand where we're going is time series modeling or other types of statistical models that give us a number in the future. So they would project or forecast a certain number at a certain date based on a retrospective trend. And that is all good. And we're not here to say that we're not going to do that, because all of these different types of methodologies complement each other and are good to do. But when we started to look at this in Sweden in 2012, because we want to set our targets to 2020, what we realized is that we can do those forecasting models to sort of understand where we're ending up in 2020. But we don't know much about what those crashes actually look like. We don't know much about the characteristics of what we call residual crashes. We don't know who they involve, what are the actual sort of circumstances around those crashes. And because we don't know that, we don't know how to target our interventions in the most effective way. And everything would have been good if we just had sort of a business as usual development and the system was not changing. But on top of that, we can see that because of the things that we're doing in the system, we're building new roads, we're having a vehicle fleet that's turned over, the system is changing and the crashes are changing. So we can't just project the crashes of today into the future, because they'll be invalid. And I might develop my strategy to target crashes that would already have been prevented with things that I've already implemented, if that makes sense. One example of that is that we could see in the year 2000, where we have fatalities in passenger cars here split by crash type, and most of our fatalities were head-on crashes, the blue bars. And then we have single vehicle crashes, intersection crashes. And then there was an extensive build out of mid barriers in Sweden. And we had the implementation of electronic stability control, and cars got safer. So head-on crashes dramatically changed to 2013, and single vehicle as well, but the proportion of them changed. So if we would have designed a strategy based on 2000 crash, or the crashes from year 2000, it would have been sort of waste of money in a sense, because we would have tried to prevent crashes that already had been prevented. So we want to understand, if we're then looking at 2020, or where we are today, 2030, what is actually in the pipeline to change the crash configuration and characteristics, so that we think that we need to take into account. And is there a methodology that we can use to actually say something about that characteristics of future crashes, because that would guide us better. The other thing that's a bit tricky when it comes to just doing sort of forecasting is that there's a non-linearity in some of these treatments that are being implemented. And I think vehicle safety is one of those typical things where there's a lag in benefit, which is sometimes difficult to understand. So when the black line here represent vehicle mileage with cars that is equipped with electronic stability control. And that comes from the fitment rate in new vehicles, which is the green line. So there's a green line where sort of new cars has been fitted with a certain technology. There's a black line that represent how that sort of translates through vehicle mileage. But then we know that the vehicles actually involved in crashes tend to be quite old. They are a different cohort. So the benefit of this technology is actually lagging, and that's different for different types of technologies, because they relate to different cohorts. And that's quite difficult to target with just mass data and statistical methods. You need to understand a bit more about the actual dynamics in crashes to understand how these systems are working. So when combining vehicle safety and infrastructure safety and sort of road user safety policies, and try to understand what the combined effect of that is, there is a timeline to take into, or time lag to take into account, that otherwise it'll be very also again invalid when it comes to projecting the benefit of this. And the last thing I want to sort of share with you is sort of in terms of the justification for this new methodology, was that there's always a challenge to calculate the combined effect of safety performance indicators or safety initiatives. We can calculate, as in this slide, the individual benefits of certain interventions, but what is the actual combined effect of this? So, for example, the effect of more sober road user or the use of seatbelts. Could we just add those two, 30 and 40 lives saved, and say that that's 70 lives saved? Well, we cannot, because these crash pools overlap, because there's a lot of road users that are impaired that is fatally injured without a seatbelt. So the combined effect of doing things of these with these risk areas is less. And you can do, again, statistical assumptions on how big that overlap is, but it would be much better if we can go in case by case to actually understand what is the exact relationship between these different risk factors, and not only these risk factors, but all other risk factors in all fatalities and injuries. So that is another sort of aspect to take into account. So when we developed this methodology to understand what future crashes look like, We want to understand what level of safety the road transport system were in a given date, and also identify necessary safety improvements and their combined effect to be able to sort of develop response scenarios and a strategy ultimately. And we had a few requirements there. It needs to be transparent to enable stakeholders to sort of understand and take part of scenario development, and needs to include fatalities and injuries. It needs to be able to describe the characteristics of future crashes, and possible to handle what we just talked about, double counting, dependencies between treatments, etc. So hopefully with that long introduction and justification, we'll get into what it actually is. So it has a few different names, but it's been done before, not only in my and Jet's research, but in other research. And the other name for it is counterfactual analysis. And it's sort of a what-if analysis. That's sort of basically what it is. And this illustrated here with sort of a chain of event where crashes happens, which is quite common to use in accident research or crash research and investigation. And this is illustrating that a crash is normally goes from a situation of normal driving, something happens that sort of makes things deviate from that normal driving, and goes into an emergent situation, critical, and then crash avoidable, and then there's an injury or fatality. Now, in that sort of sequence, we can introduce a number of different interventions that either return the car to normal driving and you continue to drive or ride or whatever, walk, or you go into a crash avoidable phase where we say that we can still mitigate the outcome of this crash by crash worthiness and barriers and protective equipment, etc. So this methodology then says that, well, if we have a crash in this case, because it's a research paper that was sort of part of my research 10 years ago, it takes crashes from 2010, and then it puts a what if question to that and say, what if this car were equipped with certain technologies? Or what if this street had safety features or safety management or speed management introduced? Or what if there was a barrier there, etc. So it designed some strict protocols around when does the system work, how do they work, and if they were in place, what crashes would they actually prevent? And then I go through all my cases, normally at least a year of fatalities and injuries in a certain jurisdiction. And I take case by case and ask these questions, whether this crash would be prevented at a given time in the future, given the implementation of a certain set of interventions. So step one, assume or try to understand what is my pipeline of implementation treatments. Is there ongoing funding for certain things that's going to happen without any additional action plans or things? Typically vehicle turnover. Step two, apply this case by case. And step three then is to try to understand a bit more, okay, here is the crashes that was avoided. Here is the crashes that I expect not to be avoided. Let's look specifically on those crashes that are not estimated to be avoided, because those are the ones that I want to focus on when I develop my strategy. What it can look like, an example is like this. So, for example, if I'm in year 2020 and there's a crash, this crash is involving BMW or any car from 2005, so a 15-year-old car. And this is an actual case in Sweden, actually. It was on an undivided two-lane, two-way road, wide sort of shoulders, some targeted barriers, and there was a loss of control. Skidded off the road, started to roll, did not use a seatbelt, was ejected out of the car, and crashed under the car, and then the car was lit on fire, and there was a fatality. And the question is then, well, if we project that to 2030, would that look different? So we take that car, project it to 2030, and in 2030, a 15-year-old car would be a model from 2015, obviously then. And that car by regulatory standard would have both electronic stability control and seatbelt reminder. We also know that we have a pipeline of infrastructure investments that's already funded and ongoing. So this road will be a 2+1 with full continuous barriers, or 2+2 with full continuous barriers. So what we then sort of say is that, well, the dynamics of the crash, the specific circumstances of the crash were such that these systems would actually prevent it. And not only the vehicle systems, but actually also the road. So the vehicle safety systems would prevent the crash from happening in the first place. But even though if the vehicle systems was not there, the road would probably prevent this crash from being a fatal crash. And then, of course, I can continue to do this up to 2040 and see that, well, this car will be even newer. It'll be a new 2025 vehicle, which have even more systems, and so on and so on. So it's pretty straightforward in terms of doing this, but of course, it's quite a rigorous system around those boundary conditions on the functionalities of the system, etc. So the first way that we actually use this is in the strategy development is to validate that end state that we were talking about. So let's say that we've defined what the road should look like, what vehicles should look like, etc. We want to understand how close to zero would that actually take us. So we have all these systems. We go through all fatalities in a jurisdiction and a country. We apply what that end state should look like. And then we say, how many of those fatalities do we think actually going to be prevented and not prevented? So solved by a safe system end state versus not. And we can see in most jurisdictions, we end up around 80, 90%. So with the already sort of accepted and used interventions, we can come pretty far. It's all about implementation, really. But then there's 10% that's normally quite a challenge. So depending on how I've designed my end state, I can use this to say that, well, these 8%, what are they? What else do I need to do? How do I need to modify and tune my system to also cover that? So, for example, I can look at those 8% and say, well, here's one crash that was deemed not to be prevented. It was a head-on crash between a heavy vehicle and a car, and it was a tire explosion on the heavy vehicle, and the barriers was not designed in my end state to be able to withstand that heavy vehicle, so there's still a head-on crash. So that gives me information, more detailed information than what a statistical method can do, to say what exactly do I need to change to actually make this not happening in my end state again. Another crash with a motorcycle, single fatality. In this end state, it's not a highway. It's more like a mid-low volume roads, which has a speed limit or a speed reduction, and a certain sort of assumptions on what the roadside area would look like. But these barriers that we would target here would not take into account motorcycles in a sufficient way. So this motorcycle crash is also expected to be in the residual crashes. And this car was an heavy truck rear-ending a passenger car, where you would think that the future AEB system would actually prevent this crash, but unfortunately there was a sandstorm in this particular case, and that would sort of obstruct the view of the sensors in a way that it would not expect to work. So, of course, you cannot guarantee that that sandstorm is going to happen exactly in the future, but what you get is a sort of an understanding of the unique circumstances when you go through enough cases, where you get a certain saturation for those unique crashes. And well, wow, okay, it'll take 90%, but there are some exceptions which we also need to take into account if we're really serious about zero, and this is one of those occasions. So I can gather all this up and I can look at my residual and I can ask myself, why are they there? Where one would be, it's actually implementation time. So let's say that we're looking at 2040 and 2050, but even then, the vehicle might be so old that the system that's going to prevent this crash is not expected to be yet implemented. And then we have the middle case, which is no relevant intervention. That was a motorcycle crash that we just talked about. And then we have what we call outside effective envelope, and that is more the sandstone that we were talking about. Like there is a system that is designed to prevent this. It will be implemented in time, but it's not tuned to work in these circumstances. So in doing this, I can get more detail around the cases, and I can design my interventions more specifically to understand, do I need to do more of the same? Do I need to do the more of the same but faster? Or do I need to do the same, but I need to actually tune my interventions in a way that it's a larger effective envelope? Or do I need to do something new? How do I need to innovate to actually include more crashes into the interventions that I have into my toolbox? Okay, so the last step that I want to talk about, because we do want to leave some time in the end for questions, is to say that, well, now I've sort of developed my end state, I've validated it, I have understood why crashes are not prevented, even though I implement that future ideal state. Now I want to grab those 90% at least that I have with my end state, and I want to understand what's the best way of getting to that 2050 end state that saves as many lives as possible. So it's really to develop that strategic response scenarios. So let's say that we have a certain baseline trauma trend. And with baseline trauma trend, we mean what we talked about in the beginning of the session as like a business as usual trend. Now, this is a pretty optimistic trend, but we've seen in the past that we have around 3 to 5% reduction per year, depending on what type of interventions that we do and the vehicle exchange, etc. So let's say that this is true. We can play up and down with traffic growth, and we can sort of see what's coming into the market. But let's assume that this is sort of a realistic future trend. And we can also conclude that it's far away from the target of where we want to be in 2050. So we set up a few principles then that we think is going to guide us in getting there. We want a strategic response that'll make us achieve this target in an evidence way, multidisciplinary. We want to actually go long term and look at that 2050 state, because a lot of strategies that's developed in the past has sort of looked at the government target and say, okay, we're going to reduce our crashes by 30% in the next 10 years. And then we come up with the absolute most cost-effective way of reducing our crashes by 30%. Problem is, though, that we go to that date, we achieve that 30%, and we're still left with 70%. And now I wasted my money on things that, not wasted, but I've managed to achieve my interim target, but I might need to redo some of my intervention to achieve the other 70%. So really, when looking at interim target, I should not develop the most effective way to get to that interim target. I should develop the most effective and cost-effective way to get to the long-term target, and then move back to say, what does that mean for my next 10 years? So that is what we mean about near-term cost-effective, but also a sustainable pathway to 2050. So it's really that mix of long-term and near-term interventions, where we also need to, of course, take into account capital cost, delivery capacity, benefit realization timelines, community acceptance, all of those political landscape, etc. So that is all sort of part of that consideration. The starting point will be to sort of list, of course, the set of intervention that's part of my end state and say, what are the benefits of introducing this? And this is one way of illustrating this, to say that, okay, I have a set of infrastructure interventions. In this case, for example, the gray bars represent how many crashes is actually relevant for this, or relevant for this crash in the first place. If I have a roundabout as an intervention, they will not target rear-end crashes in rural areas on mid-block sections. So how big is the problem relating to this specific intervention? And the red bars would be sort of using the crash reduction factor to say that, well, it's not going to prevent everything. It's going to prevent a certain proportion. And through my case by case methodology, and the functionalities of these treatments, I can then understand what the effective is. And then the green bar would be to say, well, is it actually relevant to implement this based on my vision of movement and place? So I will not install concrete barriers in an urban place, even though theoretically it would save a life. I might not want to have that type of environment and treatment in everywhere. So it need to match with what type of system and modes I want to promote. So it's really the green bars that would be sort of guiding me to what matters a lot and what matters less. And this can then sort of help me combine a set of intervention that is as effective as possible. The other thing I can get from the case by case sort of understanding is a lot of people talking about vehicle safety and that it would save the day. And it will save a big proportion of the day. But again, it'll have a lag time and it will not do everything. So I can list my different vehicle safety technologies here, and I can say, depending on the age of the vehicles involved in all the fatal crashes, when in time can I expect that these technologies kick in with their sort of effectiveness? And then I can compare that with what would it take to actually build sort of roads with barriers compared to vehicles with lane departure warning or lane keep assist. What is actually prevented by what, when in time, and how do I let that guide my investments in a good way so that I'm not either overestimating or underestimating the benefit of future vehicles coming into the market. And once I have that all that information, I can start to piece together my response scenario. So I'm starting with a baseline. Here is the same baseline that we showed, but instead we've cut it to 2030 to just sort of look at the next strategy and action plan for the next 10 years. I will then add infrastructure and speed interventions and see how far that will take me sort of on the journey to 50% reduction, if that's my target. I'll add vehicle safety to that. I can add RBT, RDT enforcement when it comes to drugs and alcohol. And I can add additional speed enforcement in this case. So step by step, I can start to understand the components on the different areas of interventions, how far it can take me, how close to my target it will take me. And then I can compare a few different scenarios and, of course, present to government, which ultimately is going to fund this, and say, here's my recommendation and here is why. And obviously, then we want to say that this is just the first step. This 2030 line is actually my first step to all the way implementing that end state to 2050 to get close to 2050. And in this case, we've built a scenario for an actual jurisdiction. This is New South Wales in Australia, where we said that the first section in 2030 is going to include sort of introduction of vehicle safety regulation, infrastructure, speed cameras, etc. And then in the next decade, we're talking more about vehicle safety system implementation and other types of safe system interventions. And then in 2040, 2050, we're sort of moving into a fleet renewal program, etc., etc. And we don't expect that this will take us all the way to zero. You can still see there's 31 crashes still left, but it's a 90% reduction, and that's a pretty good starting point. And during the course of this, we can, of course, look at those 31 crashes and see what are those, how do they look, and how do we think that we can prevent them. Now, I think I will stop there because we sort of want to leave a bit of time for questions and discussion. But I can just say that the next step is, of course, performance indicators, to say that when I'm done with my plan, I do want to make sure that I'm monitoring and evaluating my system. And this is where case by case also has a place to set target for those indicators and what they should be and how do I monitor them. But we'll leave that for another masterclass. So thanks for listening, and we're happy to bring in Nathan and Jess and see if there's any questions.
Thank you very much, Johan. That was great and really well presented. I found that very interesting. I think because I've done some similar analysis in the past as well in the GB context, I've got a whole load of questions. but I don't want this to just be a me thing. So maybe I'll kick off with a question, and then please do any questions that you've got, put them in the Q&A or in the chat. My first question was around the importance of having good data for this kind of analysis. So you talked about the importance of understanding risk factors, why crashes are happening. So we have the Stats 19 data set in Great Britain, which is our data set of reported crashes to the police. And within that, we have contributory factors that are in the process of being shifted to road safety factors that give some indication of kind of why crashes happen. But I just wondered from your context, working with maybe Swedish data or data in Australia, how important has good data been to that process, and what parts of that data in particular have been useful for you?
Yeah, I can start, and Jess can probably also speak from her experience. But I think what we would say is there is definitely a minimum viable data set that you need. And then from there, the more in-depth data you have, the better the quality you can get from your analysis. So the basic data that you need is what you just talked about, some narrative from the police, a sketch from the police, or like some kind of sketch or drawing of what the dynamics of the crash looks like, and then complemented with what we normally would have in a sort of mass crash data system, with the vehicles involved, the make and model of the vehicles, the road user involved, and etc. So that would be sort of the minimum data set. What we use in Sweden is also our in-depth investigation of fatal crashes, which will involve sort of witness statement, photos of the road environment and the crashed car, so to understand sort of impact angles and all of that. So that adds an extra dimension of things, where you can sort of look more specifically into the actual crashes. But I know, Jess, that so I know that Jess, you used sort of more than minimum viable data set in Victoria.
Yeah, I can sort of agree with what you said. There is a minimum set of data that you would need in order to be able to do that case by case analysis. But even with a very simple narrative, you'll be able to undertake that process. But of course, the richer the data that you have, the richer the information that you've got to work with after you do your analysis as well. So when I did my PhD, that was based on crash data that was available in Victoria, Australia, and that was based on police reported fatalities and injuries, supplemented by hospital data that was collected by the Transport Accident Commission. So that hospitalisation data is especially important because I actually looked at using case by case for serious injury crashes. So it's not just a matter, did they die or not, but it was also, well, what level of injury did they sustain and which part of the injury did they sustain that in their body. So once again, like the more data and the richer the data that you have, the more able you are to be able to do more in-depth analysis. And certainly for fatalities, I think that that minimum viable product that Yuan sort of talked about, that's probably sufficient. But if you also want to apply that to serious injuries as well, you probably do not need that hospitalisation, that level of injury, at least injury severity detail, in order to be able to undertake that.
Thank you. Question from Axel. So you've talked about changes in vehicle fleet and upgrades in technology. What about changes in driver or road user behavior, for example, increasing distraction due to mobile phones, etc.?
Yeah, we can include that, given that there's sort of a more thorough understanding exactly what it does. So it's not really designed to do that. I mean, it's a deterministic model in the sense that you say this crash is either prevented or not prevented. And it's difficult when it comes to certain road user behavior to say, well, just because you didn't have your mobile phone, would you not have this crash, yes or no? So what we tend to do with some of those, and it's the same with, for example, fatigue or speeding. It's difficult to say, well, if you were driving 4 kilometers per hour slower, would you have survived or not? It's difficult to do that in a binary sense, yes or no. So what we tend to do is to first do the case by case and then overlay a statistical assumption on some of these risky behaviors. So we say that this if there's certain distractions or speed or whatever, that brings another sort of risk increase to all these different elements if you have that as part of your data set. So.
Anything to add, Jess?
I would just say, I guess in this whole backcasting case by case sort of process that we're using as a part of our Vision Zero planning, we're really aiming for a future state where no one can be killed or injured. And one of the most effective ways to do that is to try to put in place measures that are not so reliant on user compliance and user willingness to comply. I mean, of course, we need them to comply in the interim while we're trying to build that foolproof system. But hopefully, by 2050, we will be able to have technologies and infrastructure that will be able to mitigate some of those human behaviors. Now, that's not to say we can allow people to do whatever they want. It's just to say there are innovations that are available already that can help influence people's behavior to the direction that we want them to head. For instance, we want people to wear their seatbelts. We've got seatbelt interlocks. We don't want people to drink and drive. We've got alcohol interlocks. So we still need people to behave a certain way, but the way to achieve that might look slightly different. It might be through the use of infrastructure and vehicle technologies rather through a more traditional educational-based approach.
Thank you. And then one last question, a big question with 2 minutes left. This is from David. So with such quick changes in technology, how far ahead do you think you're able to understand what the future will look like? And I guess on top of that, I would add, is there maybe a measure of uncertainty in this analysis? The further you go, the more uncertain the results look. So yeah, good luck, 2 minutes.
Well, I'll give a short answer to say that if yes, that is one aspect that's definitely important to acknowledge when we do this. But I think we shouldn't sort of stare us blind on the fact that there's a slight proportion of the vehicles which is very, very advanced, and in the next 5-10 years they'll probably be even more advanced than self-driving. Well, it still takes a lot of time to change the bulk of the vehicle fleet. So a lot of the crashes that we see for the foreseeable future, they will involve what we have today. So when we do like a baseline trajectory of the crashes over the next 20 years, that doesn't really have a big effect, or those sort of new technologies doesn't have a really big effect. It's lagging unless we totally change the whole vehicle fleet, which is probably not sort of realistic. So we do need to take that into account, but normally when we do it, we see that it doesn't really have a large effect. But what we do also is do a bit of a sensitivity range. So we say that, well, here's sort of the worst case scenario, is really business as usual. Here's what would happen if we implement all these new technologies with a certain functionality, and here's our best estimate. And then we sort of get a range to say that we don't know exactly where we're going to end up, and the further in the future, the more uncertainty. But at least this methodology gives you a sense for the ranges in which you sort of end up. So.
Yeah. Can I just add that the case-by-case process isn't really a set and forget sort of process. So we don't just recommend you do it once and then not look at it until 2050. So because there are emerging road safety issues that might come about that was not taken into consideration at the time when you initially did the analysis, such as, mobility scooters and, e-bikes and all that as they become more prevalent, they may make up more of the trauma issue. So we do recommend repeating this case-by-case process at least every 3 to 5 years so that you can actually repeat the process and understand, are there any emerging road safety trends and issues that also needs to be addressed now?
Great. That's a really nice way to finish. Thank you all for your time. So that concludes this webinar, this case-by-case masterclass, and thank you very much to Jess and Johan for your time and for coming to present to us. I just want to flag next webinar. So Tuesday, 13th of May, 2 p.m, we've got a webinar, a deep dive into Stats 19. So we at Agilysys, in combination with Department of Transport, have done a deep dive into Stats 19, engaging with forces gathering Stats 19 data from all across Great Britain, and we're going to disseminate some of those findings and results in that webinar. So do join us for that one as well. But we'll leave it there. All right. Have a good Friday afternoon, and see you all again soon. Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.